All right, so let's see this question. So over here we are given two strings, S1 and S2. And what we need to do is we need to find the smallest possible window in S1, which contains all the characters in S2, right, including the duplicates. So what I mean to say is that, we don't have to worry about the order or anything of the S2 characters. We just have to make sure that all the characters that are present at some point in time in that particular substring, right? And we need to find the smallest such substring. So that's the problem. And if there is no such substring at all, which contains all the characters of S2, then we just need to return -1, right? So that's the problem. Now, maybe you can pause this video right now and you can just think of a solution and then come back to have a look, how I solved it, right? So now to solve this particular question, what we can do is we can have a two-pointer approach and we can maintain a variable size window, right? So we can have a start pointer and an end pointer. Both of them will be pointing to 0th index to begin with. And, with every iteration, we will just keep incrementing the end pointer, right? And we will just keep increasing the size of the window, right? With every increment of the end pointer, right? And we will keep incrementing the end pointer till a stage when we actually have all the characters present in this S2 also present in that particular substring, in that particular window. So we will keep increasing the window till we find all the characters present in that particular window, right? That's the idea. And once we hit that particular point, now we will try to shrink that particular window size, right? So now earlier we were expanding. Now since we have all the characters in that particular window, now we will try to minimize its length, right? And how we will minimize it? We will just keep incrementing the start pointer now, right? We will just keep incrementing the start pointer and we will keep removing the starting element one by one from the window. And at every point in time, after every removal, we will keep checking if we still have, these elements from S2 present in, that particular window or not, right? And once we encounter a point when we actually have at least one missing element from the S2 in that particular window, then again we will fall back to the earlier process. We will keep incrementing the end pointer till again we have all the characters in that particular window. Again, we will try to minimize it, right? So that way, and at every point in time, of course, we will keep a track of the minimum length that we have encountered so far of such a window which has all the characters from S2. And at the end of it, we will just return that, minimum substring. So because, when we are actually keeping a track of the minimum length, we will also keep a track of the corresponding starting and the end position, which actually result in that particular minimum length, right? So we will just keep a track of that. And at the end of it, we will just return the minimum, like the substring, from the starting position to the end position of whatever we got finally, after scanning this particular string, right? So that's the intuition behind this particular problem. And to do this, we will keep track of whatever we have seen so far when we are actually scanning through this particular string by using a hash map, right? So we will first have one hash map. For example, I'll just write it over here. So we will have one hash map for string 1, right? So it will look like this, right? And one hash map we will have just for hash string 2, right? And in this hash 2, which is for string 2, we will have things like this. For every character, we will have exactly the number of times it has occurred in S2, right? So for example, T has occurred twice, then O has occurred just once, and C also has occurred once, right? So this is how hash 2 will look like. I will keep this, the number of occurrences against each of the character in S2. And similarly for S1, what I will do is uh, I will do a similar thing, but to begin with, when I'm actually declaring this particular hash map, I will keep all the characters which are present in S2 in this particular hash one, but I will keep their occurrences as 0, right? And as and when I'm moving forward or I'm like removing the starting elements, I will keep increasing or decreasing, these values for each of the character, right? That's how I will come to know whether I have seen, uh, you know, the right number of occurrences of each character from S2 or not in the current window, right? That's how this will be helpful for me. This will be a static hash 2 will be a static hash map, which I will be referencing, just to compare whether I have seen adequate amount of the required number of occurrences of each character or not. And this one, I will just keep incrementing and decrementing as and when I'm seeing or unseeing a particular character, right? That's how I will just keep a track of it. So yeah, so I think that's pretty much the intuition behind the problem. We need to use two-pointer approach over here, maintain a variable size window, and then, at every point in time, use these two hash maps to basically compare if we have seen all the elements in the current window or not, and then accordingly we can try to shrink the window or we can expand it further, right? So that's the intuition. Now maybe you can try to write the code for this particular approach, and otherwise maybe you can code along with me. So let's jump to the IDE and write a solution, implement this solution. Okay, so let's implement this function over here, the smallest window function, and it takes two variables, two strings, s1 and s2. And let's write our implementation of the solution here. So to start with, let's declare the two hash maps that we are going to use. Hash1, let's keep it empty for now. Hash2, also keep it empty for now, right? Let me also declare n1, which will have the length of string 1, and n2, which will have length of s2, right? Now what I will do is I will loop over my string 2, and for every character in my s2, I will make an entry in hash2 as well as in hash1. In hash2, I will have the values of each of the character as exactly the number of times it occurred in s2, right? Whereas in hash1, I will just keep an entry of every character. I will not I will keep everything as 0. For every character, the value will be 0 for now. And as and when I'm scanning s1, I will keep incrementing or decrementing that particular value in hash1, right? So I will do something like this for I in range n2, because I'm looping over s2, right? I will just check if I've already came across the current character. So I will do if s2 of I in hash2 already. Then I will just update this value by 1, right? I will just increment this value by 1. Else I will just create a new entry and initialize it to 1, right? And also finally, I will also make an entry in hash1 for this particular character, and I will just update it to 0. So if I've seen it before, still it will be 0. If I haven't seen it before, I will be just updating it to 0, right? So this is what I will be doing under this for loop. Now maybe what I will do is I will create a bunch of variables. So first I can declare a start pointer, initialize it to 0. I will declare an end pointer, also initialize it to 0. I will create a minimum starting pointer. I'll just tell what it means, and min end pointer as well, and also initialize it to -1. Now, why I'm creating these two pointers is because I need to, at any point in time, whenever I find the minimum length window, I will keep a track of the corresponding minimum starting point and the minimum ending point for that particular minimum length window that I have came across so far, right? So because if I don't find at the end of the scanning, if I don't find any window smaller than that particular window, I will simply return the substring from S1 between these 2 points, right? The minimum starting point and the minimum ending point. And that will be my minimum length window, which contains all the characters from S2, right? So that's why I need to keep track of, these two variables, because see, as my output, I need to actually return the actual substring. I just don't need to return the length of the minimum, the substring. I also need to return the actual substring. And so for that, I also need to maintain these two variables to, define from where till where my window is actually extending, right? That's why I need to maintain these two variables. Along with this, I will maintain another variable to keep a track of the current window's length, right? Initialize it to 0 for now. And similarly, I will also declare a variable to keep a track of the minimum length I've encountered so far. And this I can initialize it to n1 because it cannot be greater than n1, right? The minimum length. It can be the entire string, but it cannot be greater than that. So I will start with n1 and then I will keep decreasing it as and when I encounter anything less than that, right? So that's the entire idea of these variables. I will also declare one more variable, which is count, right? Now, what is the meaning of this count? What is the purpose of this count? So what I will do is that, as and when I'm actually encountering a valid character in my S1, which is present in S2, I will keep incrementing count, right? And the moment the value of the count becomes equal to N2, which is the number of characters in S2 totally, whenever it becomes equal to N2, I can say that I have found a valid string, valid substring, which contains all the characters from S2 in this particular window, right? So that's how I will actually identify a window which is a valid window, right? An eligible window it can be like, it can be minimum or it cannot be minimum, that's a different thing. But this count variable will actually help me in identifying a valid window, right? So that's why I'm using this count variable. I will keep incrementing it as and when I find a valid character, right? And then I will keep comparing it in every iteration if it is equal to n2 or not. So this is how I will do it actually, while n is less than equal to n1 minus 1, right? So I will go till the end of s1, right? And for the current character, I will check whether this particular character is actually a valid character or not. When I say valid, I mean to say whether this character is actually present in S2 or not, right? If it is present in S2, it will definitely be present in hash1 also. And that's why I will just check with this particular condition, right? If it is present in hash1, I will just update its value by 1. I will just increment its value by 1, right? Right? And now I will increment the value of count because now I have encountered a valid character. So I will increment the value of count. But before incrementing the value of count, I will have to check one more condition, which is if the value of this particular character in hash1, right? Actually, I should have written s1 end over here. Yeah, and similarly s1 end over here, right? Yeah. So if the value of this particular character in hash1 is less than or equal to hash2 value, right, for this particular character, only then I am supposed to increment this particular count variable, right? And why so? Why do I have to check this particular condition? Because say for example, uh, there are multiple t's, right? There is a character t which is occurring 3 times in this particular window, right? But it occurs only twice in S2, right? So because it is occurring thrice in this particular window, if I don't check this particular condition, I will end up incrementing count for the third occurrence as well, right? But I don't have to do that. T is definitely like a valid character because it is present in hash1, right, over here. But then I also have to check whether, I have already encountered the required number of occurrences of that particular character or not. If I've already like seen the required number of occurrences for that particular character, I don't have to increment the count because then that's like useless for me, right? If I increment count, my algorithm will give me wrong results, right? It won't consider, I mean, for example, if there is a missing character in a particular window, there is an extra t, but then there is another missing character in that particular window, right? My algorithm will get a delusion that actually it has encountered all the characters, but actually it has not. It has encountered one valid character multiple times, right? More number of times instead of, actually encountering all the valid characters, right? So I hope you got it. So that's why we need to check this particular condition that the number of times that we have seen this particular current character in hash1 in s1 should be less than or equal to the number of times it occurs in s2. Only then we need to we are supposed to increment the count variable. Otherwise we will just skip it, we will just ignore it. We will just treat it like any other character, right? So that's the idea behind this particular line. Now what we will do is we will just over here we will check if my c and t, the count variable, is equal to n2, right? Now, why while and not why not if? Because if you remember, we have discussed that uh, till we have this particular condition valid at any point in time, we will keep incrementing our starting pointer, right, and keep removing one element from the beginning, right? So that's why we can make a use of while loop inside of this and keep incrementing the starting position and keep removing one element till we have this particular condition true. And this condition basically gives us the uh, message that whatever characters are present in S2, they are already encountered in the current window, right? So I hope I'm not speaking too much. I'm just making sure you understand what I'm writing. That's the whole idea of code along, for me at least. So yeah, so now I will just update the length, right? So while CNT is equal to N2, I will say L is equal to N minus ST plus 1, right? So I've just updated the new length. That's the only thing I've done. And now I will check if my current minimum length, whatever I have in my current minimum length, is greater than L. That means L is less than minimum length, basically. If that's the case, I will just update minimum length by 1, by L, right? I mean, I will just reassign minimum length with L, and I will also reassign minimum ST to the current ST, right? The starting position. And I will also reinitialize the minimum end position with the current end position, right? Because this is the new minimum length that I have encountered. So that's why I need to reinitialize the minimum starting and the minimum ending point, right? Now, what I need to do is, now I need to check, now I need to remove basically every element from the beginning, each element one by one from the beginning, and keep checking whether this particular condition holds true still or not, right? So for that, what I can do is to check first of all that, the current character at the starting position, whether that is a valid character or not. I will again use that particular condition that I used in the beginning. I will check whether that particular character is present in hash1 or not. If it is present, then again I will check whether the number of times it has occurred in S1 in the current window, right? It should be less than or equal to the number of times it has actually occurred in S2, right? So that's why I will check it for its value in hash2, right? If that's the case, then I will decrement the count variable by 1, right? Because now I have removed one valid character from the window, right? So that's why this is the case I need to handle. And then I will just decrement its value in hash1 also, because now I have removed the character from the window. So whatever its value is currently in the hash1, I will just decrement it by 1, right? I've removed it. It's one of the occurrences, right? And finally, I will just move the starting pointer to the next position, right? st plus equal to 1, right? So this is what I'm going to do. And then finally, after we have done all of this, I will just, I will just increment the end pointer, right? Because now see, once we get out of this while loop, I will come over here and I will now start incrementing my end pointer again, right? Till I'm meeting this particular condition, I will keep incrementing my starting position. And once I'm done, once my count is not equal to n2, I will just come out of it and I will keep incrementing my end pointer, right? So that's how I'm going to do it. And finally, I will terminate after I, violate this particular condition, correct? So once I'm out of this particular loop, I have to return the whatever I have finally found out in minimum st and minimum endpoint, right? The substring between that is what I need to return. So what I can do is I can just uh, return, I can use string slicing over here. So I can do return, and let me just correct this typo. The whole string from minimum st till minimum end plus 1, because I also have to include the minimum end index, right? And then, yeah, I think that's pretty much it. That's what we need to do. Let me just have a look again, because we are just scanning the entire S1 till we reach the end index. And then we are checking if this is how we are checking if the given character is a valid character or not. And at any point in time, after we have added one element to the window, we will keep checking if my count is equal to n2 or not, if it is if it is a valid window or not. If it is a valid window, I will keep updating my minimum length, and I will keep incrementing my st, keep removing one element from the beginning. And the moment my count becomes less than n2, that's the time I will break and I will again keep incrementing my end. I think this looks good to me. What we can do is we can test this by running a simple test case. I can print, this particular, the output of this particular function. And I think we can use the same test cases that we used earlier, like while we were defining this particular problem. So it was time to practice, and over here it was TOC. So let's test this particular function now. So I've just written a print statement. I have called this particular function with the sample test case, and the output of this particular function should be this particular substring, TOPRAC, right? That should be the output of this particular function, because that is the minimum window in this particular string, which contains all the characters which are present in this particular string S2, right? So that should be my output, TOPRAC. Let me just run this now. Okay, so it gives me a blank. Okay, so if you see over here, this return statement should, like, I've written it inside of the while loop. Mistakenly, it should be outside the while loop at the end of the function. So that's the mistake, I guess. Let's run it again. Yeah. So now if you see, we have got the right output, TOP-RAC. So this is entirely the solution of this particular problem. I hope you understood it well. And do let me know in case of any feedback if I should explain a bit less while I'm coding along, or I should explain more, I should be more explicit, I should not speak too much. Do let me know your feedback and I will try to include it in my future videos. Thank you so much.